Hi, everybody. Today we're going to be talking about waves. I've adapted this screencast so that we can do this kind of activity remotely. Normally what we do this in class in small groups. Every group has a little wave, and you guys play with the waves and find things out that way. But this is going to be a little different. So if you do have a wave at home, or not a wave, a slinky at home, make sure to be safe with it, or springs, be safe with those. Don't rub them against the table or floor. Don't stretch them. If you get a kink in it, try and fix it right away. Be careful with it. But most of us are going to be using a simulation today. So what I want you to do is either practice creating waves, just kind of playing with these slinkies, these wave simulations, to try and figure out some things. Describe what you see, keep track, illustrate things, or take screenshots, all that sort of thing, so that you can add it to your notes. So I want to show you how you would add things to your notes. So what you're going to do once you get a chance, you're going to go to your Google Classroom. I've made this in my AP Biology so that you guys don't see it and then I can erase it. But anyway, you're going to click on the assignment. It's Slinky Waves, Remote Guided Notes. And I've logged in as a student. And you have right here Slinky Waves doc. So you click that. It's going to open your own copy. So on the left here, you have kind of this question: describe, show pictures of the waves you create. So that's what we're talking about right now. So you can add things to those notes. You can type it, describe it. You can paste in pictures of screenshots. If you wanted to, you really could print this out and then draw on it. I don't know. It's up to you. So let me go back to our document here. And then you're going to end up writing a question just like it said in the notes. So here's a screenshot of my wave simulator. You can, if you go to document, click on the link, you can type in the link. I'll also have a link linked in your Google Classroom assignment, but you want to pause everything and get to this link. All right, so what we have this little row of balls that are attached, and you can make a length and a little wave, and you can do it where it's a pulse. You can open the end. I kind of like having no end here so that the wave just goes through, but you can play around and find things that you discover. I can have it make the wave on my own, so I can adjust how high it is. I kind of like it really tall. I can make it slower or faster. I can add a ruler so I can kind of look at how long those waves are. I can do all sorts of stuff. So play around with that for a little bit. And remember, you might want to take a couple screenshots to add into your notes, that sort of stuff. All right, so I'm going to go back again. All right. So what did you figure out? Think about that. Add that to your notes. You're sharing out into your notes since we're not doing this as like a whole class discussion. And so now in your notes, or write things down so you can add them to your notes later, we are going to just talk about these different types of waves. So the first type of wave that we have here is a transverse wave. And transverse waves, excuse me, transverse waves are the waves that go like this. They go up and down and up. And so that's kind of like what you normally think of wave. That's not the only type of waves out there, but that's probably what you that's what we end up making with simulation. If you have Slinky, that's probably what you ended up making with that. Though you can make other types of waves with a Slinky. The other type is a longitudinal or compressional wave. And so here we had, up here we had the peak and the trough, right? Here we have these compressions, which are the tight parts, and the rarefaction. And if you have an old school corded phone, you probably have that phone cord that kind of looks like this, and you may have played with that. All right. So you should spend some time in your notes, either drawing or taking pictures and putting into your notes what these different parts are. So the baseline right here is halfway in between the peak and the trough. You can kind of think of this as the 0 line. Another thing that we can measure are wavelengths. So how long is that wave? So there's a couple different ways we can go. It can go from trough, from where it reaches the baseline to where it reaches the baseline there and there. All right, so that's one, let me fix that. That's from baseline to where it reaches the baseline there and there. That's one full length. Or you could go from peak to peak. That's one full wavelength. And you can go from trough to trough. That's one full wavelength. And you can check that with the ruler. You can go through and measure and make sure, hey, is that the same? And you'll find that that's the same. And right up here, we have this Greek letter lambda, which represents wavelength. So instead of writing wavelength out every time, you can just make the Greek letter lambda. So if you're doing that, you just go, oops, and that. So that's not the greatest one, but you can practice. It's hard to do on the computer here. And that's our Greek letter lambda. Right? Amplitude is indicative of how tall the wave is. And the wavelength should be, if it's a regular wave, the amplitude should be the same above and below. Okay. Frequency is how many waves are in a given amount of time. So if this all equals 1 second, then we have 2 waves there. We have the yellow one and we have the green one. Oh, not 2, but 3. We have 3 waves there. So this is 3 waves in 1 second, which is the same as saying 3 hertz. So we have 3 waves in 1 second. Let me go back. 3 waves in 1 second, which is equal to 3 hertz. So that's our unit, right? And that's our unit equation. All right, so what is the frequency of the wave shown? We kind of just talked about 3 waves in 1 second, or 3 hertz. So here our answer is 3 hertz. Right. So another type of wave, again, back to that longitudinal wave, we have the compressions and rarefaction. So we need to know what that is. So our wavelength is 1 compression plus 1 rarefaction. All right. Here's a little simpler drawing of it. I have where we see our wavelength there. And if we had 1 second, we want to know what's the frequency of that wave. And again, the wavelength is 1 complete compression and 1 complete rarefaction. So I have 1, 2, 3, 4, 5 waves. So 5 waves in 1 second equals 5 hertz. So now, a little different, we have a different wave, and we have 2 seconds. So things are going to be a little different. So go ahead and try and do this on your own. I'll give you a second to pause and try it on your own. All right. So now I'm going to go through and count this. So I have 1 wave, 2 wave, 3 wave, 4 wave, 5 wave, 6 wave, 7 wave, 8 waves. I have 8 waves in 2 seconds. So that equals 8 divided by 2 is 4. It's going to be 4 hertz, right? That's my frequency. Bam, 4 hertz. All right, so we're going to pause right there, go back, fill out your notes. Remember, you have to do Cornell notes, so that means you're going to write some things down, maybe draw a picture, label them. You can type it, you can take screenshots and put it in, whatever you want to do. Write summaries of what you learned, and then you're going to turn that in. All right, so let me go ahead and stop this video, and you guys should be good to go. After this video, the next day, there's another assignment where we're actually going to do a claim evidence reasoning. It's like a little mini lab, and we'll do that. Thank you very much. Have a great day.